Hey everyone, and welcome to the Explainer. Today we're diving into a genuinely fascinating solution to one of the absolute biggest hurdles in deep space exploration. We're going to explore the MARS-ANDEAN food system. It's this incredibly elegant concept that blends the ancient agricultural wisdom of Earth's Andes Mountains with some seriously cutting-edge space tech.
So, think about this massive logistical nightmare for a second. How exactly do you feed an entire crew of 15 people on the surface of Mars for 500 days, or sols as Martian days are called, without them completely losing their minds, or just as importantly, their muscle mass? The stakes here are absolutely astronomical, both biologically and psychologically. Because let's face it, spending 500 days in a tin can with 14 coworkers is hard enough without a terrible menu.
And history gives us a really stark warning about this. Listen to this quote that summarizes 60 years of spaceflight experience. In Mercury, astronauts underate because the food was unappealing. In Gemini, monotony caused weight loss. In Apollo, we learned food is an emotional anchor to Earth. This is the very real, very deadly threat of menu fatigue. Surviving deep space isn't just some math problem of counting calories. It is heavily dependent on sensory stimulation. It's about morale.
Okay, let's dive into our roadmap for this explainer. We'll start with the overarching problem, the Martian food challenge. Then look at the 50-50 hybrid solution, explore farming in Martian clay, break down the Nutri Power Ball, examine the psychosocial engine, and finally, look at simulating survival.
All right, Section 1, the Martian Food Challenge. Let's lay out the raw numbers. 15 explorers, 500 souls, 0 room for failure. Every single day, a crew of this size requires a massive volume of nutrition. We're talking an average of 3,035 kilocalories per person per day. But here's the catch, right? Relying 100% on packaged food shipped all the way from Earth is just way too heavy for the spacecraft. And on the flip side, as we just learned, a diet of purely monotonous space rations is intensely psychologically draining over a year and a half.
Which brings us to Section 2, the 50-50 hybrid solution. The MARS-ANDEAN system elegantly solves this logistical nightmare by splitting the architecture perfectly down the middle. Exactly half of the required calories come from high-density 5-year shelf-life goods that are prepackaged and brought from Earth. The other half, that comes from fresh, in-situ crops grown right there in the Martian habitat.
It's really interesting to contrast these two halves. The Earth inventory is all about prepackaged resilience, stuff that packs a huge punch but takes up very little space. We're talking about highly specialized power coal protein, honey, coconut oil, spices, and dehydrated fruits. Then the in-situ inventory provides that high-volume, psychologically vital autonomy of fresh food. These are your complex carbs and healthy fats, unica potatoes, millet, quinoa, sesame, and peanuts, all cultivated millions of miles from home.
Let's shift our focus to Section 3, farming in Martian clay.
Now, what's really fascinating here is the connection between ancient Earth and ancient Mars. The European Space Agency's ExoMars mission recently confirmed massive deposits of ancient clay in a Martian region called Oxyaplanum. And as it turns out, this perfectly mirrors Peruvian Chacco clay right here on Earth. By using this Chacco clay as an exact biological analog, the team proved we can actually farm directly in Martian-like soil.
When you walk through the in-situ production, the efficiency is pretty wild. By growing the primary carbohydrate, the unica potato, in that clay substrate, the system actually saves 30% on water consumption compared to traditional hydroponics. Meanwhile, highly efficient hydroponic systems like deep water culture and ebb and flow beds handle the rest of the essential grains and fats. So your millet, quinoa, sesame, and peanuts are all grown in an incredibly optimized, low-waste setup.
Moving down to the micro level, Section 4, the Nutri Power Ball.
So what makes this a fourth-generation functional food? Well, it's essentially a high-energy, totally crumb-free nutritional staple engineered specifically to combat the physical degradation caused by microgravity. And that crumb-free design is absolutely vital. Floating crumbs in space can severely damage sensitive spacecraft avionics. But beyond just protecting the ship, this little thing delivers an intensely dense payload of nutrition to the crew.
When you break down the anatomy of one of these Nutri Power Balls, it's basically a bite-sized marriage of that 50-50 system we talked about. You have the in-situ components, complex carbs and essential fats from Martian-grown millet, quinoa, and peanut paste. Then you bind all of that together with the Earth-supplied components, the honey, the coconut oil, and that patented power coal protein.
And here is the absolutely crucial number to remember, 300%.
The POWER COHL protein used in these balls offers 300% better physiological absorption than conventional products. In the microgravity of space, where astronauts suffer severe bone and muscle loss, an absorption rate this high is a literal game-changer. It's the ultimate biological shield for long-term health.
Let's zoom back out for Section 5, the psychosocial engine.
Before we get into the mental health aspect, just look at how beautifully the habitat sustains itself physically. This is an elegant zero-waste closed loop. The crew's output, things like urine and exhaled CO2, gets filtered and fed straight into the biomass and water loop. This fuels crop photosynthesis, which in turn outputs fresh food and oxygen right back to the crew. The explorers and the crops literally keep each other alive.
And to combat that dreaded menu fatigue, this fresh food is rotated on a 14-sol cycle designed purely for sensory variety. Instead of drinking gray protein sludge day in and day out, imagine astronauts eating crunchy millet, rich creamy peanut soups, and dishes infused with aromatic earth spices that instantly trigger memories of home. This sensory stimulation, paired with structured communal meals, is exactly what saves the crew from sensory deprivation and isolation.
Finally, Section 6, Simulating Survival.
Of course, this isn't just theory. To prove this actually works, the team ran a full 500-sol mathematical simulation using a custom Python biosim model. They accounted for crop yields, daily water usage, exact calorie consumption, and even potential system failures, completely validating the entire mission architecture.
And the simulation metrics are incredibly promising. Let me rapid-fire these for you. Over 500 sols, the system reliably generated 3,500 kilograms of Unica potatoes and 350 kilograms of Nutri Power Balls. It met 102% of the crew's daily caloric requirements and 104% of their protein needs. And most importantly, bone and muscle mass degradation was strictly limited to under 5 to 7%. This proves the crew survives with a near-perfect nutritional profile, well within acceptable limits for physical degradation.
So I want to conclude this explainer with a pretty powerful thought. If we can engineer a zero-waste, high-yield food system perfectly optimized for the dead soil of Mars, what is stopping us from doing it right here on Earth? The exact same technology used in MARS-ANDEAN could completely revolutionize disaster relief farming in degraded soils or maximize efficiency in urban agriculture today. It's a fascinating look at how reaching for the stars might just provide the exact blueprint we need to save our own planet. Thank you so much for joining me on this explainer, and keep asking those big questions.